Good morning, YouTube. So this is my Vera home automation controller display. I've just showed you a video where I put together a third AC diversion load. So this is a 600 watt light dimmer that I have under Z-Wave control, and it's controlled by the Vera home automation controller through this device here that I call P-Leg Solar. So I'll show you what that looks like in just a minute, but down here off screen I have my two existing diversion loads. So these are basically the same thing, 600 watt light dimmers, and I have one on line 1 and I have another one on line 2, and what I've just added is this third diversion load, which I've added to line 2, and I want those two diversion loads to work together. The reason I've added this third diversion load up here was in my original design of this system, they both basically worked independently of each other, but then I added this what I call whole house feature here. That's this virtual switch number 3, and with that feature I can combine these two diversion loads. One of the features I added early on was the sharing mode. So if I had 200 watts of excess power on line 2 and I had 200 watts of excess load on line 1, I could let the load here use up the power here, and that works really great. It's a really nice feature. So just like the sharing mode, I also added this assist mode, which is basically the same logic as the sharing mode, but the idea is if this light dimmer got up to 100% and I couldn't use up all the excess power and I had 200 watts of excess power, I have this assist mode that the dimmer on line 1 could jump in and go up to 200 watts and use up the excess power that's down here. The reasoning behind adding this third diversion load is that instead of having this separate independent load help this load, I just added a third diversion load here, diversion load number 3, into the mix, so that now diversion load 2 and 3 work together. So let me show you the code here. This is the program logic event generator, and it's my solar device. Most of the changes were here in this conditions or automation logic. Yeah, so here's where I started making the changes. The main change I had to do was through the code, I had a number of hard-coded numbers in here. I still have some, like there's a lot of zeros in there. Each of these diversion loads are light dimmers, and the dimmers go from 0 to 100% on. So 100 means the dimmer is fully on and it can't go any higher. And so I used to have a lot of 100s or 99.5s sprinkled all over the code, and those were used to tell is the dimmer maxed out or not. Well, I had to get rid of that because I needed to add to the dimmer capacity. So I've added this conditional expression here called diversion load 2 maximum setting, and I have that set to 200 now because I have two light dimmers. So the first one can go from 0 to 100, the second one can go from 0 to 100, and if you put them together, that's 200. And then what I also had to do was I used to have these what are called device parameters. So this parameter says what is the current dimmer setting on that dimmer, and you can see the current setting is 4.69%. That light dimmer is actually on right now, but what I had it do was this conditional expression now totals up how much is the first dimmer on and how much is the second dimmer on, and give me the total. So those were three things that I added here. So I don't refer to any of these device parameters in the rest of the code. Everything's done through this conditional parameter. Yeah, so for instance, here's one where this is the assist mode, and you can see here I use this conditional expression. So now I use this maximum setting variable -1. These are floating point numbers, so you can't just do equal to 100 because it might never be exactly 100. And then I add up the total, and then right down here I calculate this new setting. I use that maximum setting again. So I work off of the 200 total. And then I have this damped setting, the same thing. It's all computed with conditional expressions or variables, not the physical device properties. And then I go and compute this flag that says, do I need to update the dimmer? So I just figure out, has anything changed since last time? Right now it's false, but if it were true, the third light dimmer handles 0 to 100, and that's what this code does, is it takes the new setting and it says if it's greater than 100, set it equal to 100. If it's less than 100, just use the current setting. And I do original diversion load. If the new setting is greater than 100, take the new setting and subtract 100. Otherwise, it's 0. So if it's 120 is the new setting, if I subtract 100, that's equal to 20. And if it's less than 100, this dimmer should be off. And you can see down here, I added the same code for diversion load number 1. And that one only goes 0 to 100 because it's only one dimmer. The only other thing I had to change here was under the logic actions, like what do I do when I update diversion load 2. So that's change diversion load 2. And if we look at the edit here, I take diversion load 3, I set that to diversion load 3 set point, and I take diversion load 2 and I set that to diversion load 2 set point, and then I restart my timer here. Pretty simple once I got all of the code figured out. The hard part was figuring out how to fit this third diversion load or third light dimmer in here without making huge changes. So yeah, I wanted to make the code changes relatively simple so that in the future maybe I take this diversion load, which right now you can see it's running at 8%. So I might want to move this over onto line 1. Or I might want to add a fourth dimmer on line 1 and keep 2 dimmers on line 2. So you can see I have those running here. So let's see if this one kicks in. Oh, we're getting a cloud edge effect right now. So that's one thing I've been wanting to check. I haven't seen load 3 and load 2 working together yet. But you can see right here, diversion load's shutting down because there's enough load in the house that it doesn't need to be running. So if I catch a cloud edge effect here, I'll try to cut back in. If not, I'll end the video here. And as always, thanks for watching.